Picture this. An alien, located 65 million light-years away from Earth, is peering through a powerful telescope. What do you think they see? Let's dig a little deeper into this fascinating scenario. We have an alien, somewhere out there in the vast cosmos, a staggering 65 million light-years away from our planet. This extraterrestrial being is looking at Earth through an incredibly powerful telescope. Now, what do you think they see? Could it be possible that they're gazing upon the long-extinct creatures we know as dinosaurs? The thought is mind-boggling, isn't it? Dinosaurs roamed the Earth millions of years ago, and yet, could an alien observer in the present be witnessing their existence from a distant galaxy? The answer to this intriguing question lies not in the realm of fantasy, but in the fundamental principles of physics, specifically, in understanding the concept of light years and the speed of light. You see, when we talk about astronomical distances, we often use the term light year. It's a measure of distance, not time, despite what the name might suggest, and it's key to unraveling our cosmic mystery. But before we dive into the nitty-gritty of light years, it's important to appreciate the sheer scale of the universe we're dealing with. The numbers are mind-boggling, and they're crucial to understanding the journey that light undertakes across the cosmos. You might be wondering how all of this ties back to our original question. How does understanding light years and the speed of light help us determine what an alien, located 65 million light years away, might see when they look at Earth? Well, it has to do with the way light travels and the time it takes for that light to reach different points in space. To solve this cosmic riddle, we must first understand what a light year is. So, what is a light year? No, it's not a measure of time. Rather, it's a measure of distance. It's a term we hear often, especially when talking about space and the cosmos. But what does it really mean? Let's start by looking at light itself. Light is the fastest thing we know of in the universe. It zips along at a mind-boggling speed of approximately 186,000 miles per second. That's fast enough to go around the Earth 7.5 times in just 1 second. Imagine that, 7.5 times around our planet in the time it takes to snap your fingers. Now, if we take that speed and let it loose for an entire year, non-stop, we end up with an almost unimaginable distance. That's what a light year is, the distance light travels in 1 year. But how far is that exactly? Well, hold on to your hats, because this is where things get a bit wild. In 1 year, light has the time to travel around 6 trillion miles. That's 6 followed by 12 zeros. It's such a vast distance that it's hard to even comprehend. It's far beyond anything we encounter in our everyday lives. You see, the universe is so incredibly vast that our usual methods of measuring distance, like miles or kilometers, simply don't cut it. They're just too small, too insignificant on a cosmic scale. That's where the concept of light years comes in. It allows us to measure these vast cosmic distances in a way that's a bit more digestible, albeit still mind-boggling. But why does this matter? Well, when we look into the cosmos, we are not just looking across space but also back in time. Light takes time to travel. So, the light we see from distant stars and galaxies has been journeying through space for years, decades, centuries, even millennia before it reaches us. In essence, when we gaze at the night sky, we are seeing the universe as it was, not as it is. The farther away something is, the longer its light has been traveling to reach us, and the older the image we see. This concept is crucial to understanding our main question, whether an alien located 65 million light-years away, peering through a powerful telescope, could see dinosaurs on Earth. Now, understanding that a light year is the distance light travels in 1 year, let's delve deeper to unravel our main question. Imagine if you could hitch a ride on a beam of light, traveling at a staggering 186,282 miles per second. Where would you end up? Now, let's embark on an incredible journey, a journey of light. Our journey begins at its source. This could be anything that emits light. A star, a light bulb, or even a firefly. The moment light leaves its source, it embarks on a cosmic journey at a speed so fast, it's almost unimaginable. To give you an idea, light could circle the Earth 7.5 times in just 1 second. As this light travels, it carries with it an image of its source. This is because light doesn't just travel in a straight line. It also travels as waves, carrying energy and information with it. So when light from a star millions of light years away finally reaches us, it brings with it a snapshot of that star as it was when the light we're seeing began its journey. But how exactly does this light reach our eyes or a telescope? Well, once the light reaches Earth, it enters our atmosphere. The atmosphere bends the light slightly, a process called refraction, which allows the light to reach the surface of our planet. Our eyes, or a telescope, then capture this light, with our brains interpreting the information it carries, creating the images we see. So, when you look up at the night sky, you're not seeing the stars as they are right now. You're seeing them as they were when their light set off on its journey through space. For instance, the light from a star that's 4 light-years away, like Proxima Centauri, our closest stellar neighbor, left that star 4 years ago, so we're seeing Proxima Centauri as it was 4 years in the past. Now imagine a star that's 65 million light-years away. The light we're seeing from that star today actually began its journey 65 million years ago. That's around the time the dinosaurs roamed the Earth. So if there was an alien on a distant planet around that star looking back at us with a powerful enough telescope, they'd be seeing Earth as it was 65 million years ago. They'd be seeing the age of the dinosaurs. This fascinating concept underscores the beauty and mystery of our universe. It highlights how our understanding of space and time is intrinsically linked to light and its incredible journey across the cosmos. Remember, when you gaze at the stars, you're actually peering into the past. How is it possible to see into the past? Sounds like something straight out of a science fiction novel, doesn't it? But the truth is, it's not fiction at all. It's reality, and it's happening every time we look up at the sky. Let's break it down. When you look at anything, whether it's a tree in your backyard or a distant star, you're not seeing it as it is right now. You're seeing it as it was when the light reflecting off it began its journey to your eyes. This is due to the finite speed of light, which travels at an incredible but finite speed of about 186,000 miles per second. Think about the sun, our nearest star. It's about 93 million miles away from us, and light from the sun takes about 8.3 minutes to reach us. So when you're sunbathing on a bright summer day, you're basking not in the current sun, but in the sun as it was a little over 8 minutes ago. Quite fascinating, isn't it? Now let's crank the scale up a bit. When you gaze up at the night sky and spot the North Star, also known as Polaris, you're not seeing it as it is today. Polaris is approximately 433 light-years away. This means that the light we're seeing from Polaris right now actually left the star around the time Galileo first pointed his telescope at the night sky. We're literally looking centuries into the past. Consider the Andromeda Galaxy, our closest galactic neighbor. At a distance of about 2.5 million light-years, the light we see today started its journey when our ancestors were crafting stone tools. And the farther out we look, the further back in time we see. This is the concept of seeing into the past. Every time we look up at the stars, we're not just stargazing, we're time traveling. We're catching a glimpse of cosmic history, a celestial snapshot of moments that occurred long before we existed. So, when we think about our hypothetical alien friend located 65 million light-years away, the concept remains the same. If this alien had a powerful enough telescope pointed at Earth, they wouldn't be seeing us as we are today. Instead, they'd be seeing into Earth's past, back when the dominant life forms were not humans but dinosaurs. This concept brings an entirely new perspective to our understanding of the universe, doesn't it? It's not just about distances, it's about time. So, as we continue to explore the cosmos, remember that we're not just exploring space but also time. We're not just astronomers but also cosmic archaeologists peering back through the ages. So, if we're always looking into the past, could our hypothetical alien be seeing dinosaurs? Stay tuned as we delve deeper into this cosmic riddle in our next segment. Let's return to our alien 65 million light-years away, peering at Earth through its telescope. Our extraterrestrial viewer is trying to get a glimpse of our planet as it was during the time of the dinosaurs. Now, why would this even be a possibility? It's all about the speed of light. Light, the fastest thing in the universe, travels at a staggering speed of approximately 186,282 miles per second. That means, in a year, it can travel about 6 trillion miles, a distance we refer to as a light-year. So when we say our alien is 65 million light-years away, it means the light it's seeing from Earth started its journey 65 million years ago. During that time, Earth was a very different place. Dinosaurs roamed the land, the continents were in different positions, and the climate was unlike what we know today. If our alien is seeing this light, it is essentially looking into Earth's past, a past where the mighty T-Rex was the king of the jungle, and enormous sauropods grazed on lush vegetation. But before we get too excited, let's consider the practical challenges. For our alien to see a dinosaur, the image of that dinosaur has to travel across 65 million light-years of space without being distorted or absorbed. Space isn't empty, it's filled with dust, gas, stars, galaxies, and all sorts of cosmic phenomena that can interfere with light. Also, consider the fact that our alien is trying to see an object on Earth, a tiny planet in the vast cosmos, from a distance of 65 million light-years. That's like trying to spot a single grain of sand on a beach from miles away. Even with the most powerful telescope, resolving such a small detail from such a massive distance is a monumental challenge. Then there's the issue of light itself. Light from Earth spreads out as it travels, becoming dimmer and dimmer. By the time it reaches our alien, it's incredibly faint. It would take an unbelievably sensitive instrument to detect it, let alone form a clear image. Despite these challenges, it's theoretically possible, if our alien has technology far beyond what we can currently imagine, that it could see Earth as it was 65 million years ago. But even then, it's more likely they would see a blurry, faint image of our planet, not the detailed scenes of dinosaur life we might hope for. So, while our alien friend might struggle to see a T-Rex on its morning hunt, the idea isn't entirely out of the realm of possibility. It's a tantalizing thought, a testament to the wonders of the universe and the fascinating nature of light. Who knows what incredible sights are waiting to be discovered in the vast cosmic ocean? We've journeyed through space and time, all from the comfort of our seats. We've delved deep into the cosmos, unraveled the enigma of light years, and sped along with the light at its breathtaking speed. All of it to answer one tantalizing question. Let's take a moment to revisit the celestial concepts we've explored. We began with the concept of light years, a measure that helps us comprehend the enormous distances in the universe. A light year, as we've learned, is the distance light travels in 1 year, and it's no small number. Light, the fastest thing in the universe, travels at a staggering speed of roughly 186,000 miles per second. And what about the journey of light? It's a voyage that takes us back in time. Because of the finite speed of light, when we look at distant objects, we're seeing them as they were in the past. The farther the object, the further back in time we see. This brought us to the idea of an alien located 65 million light-years away, peering at our planet through a powerful telescope. Theoretically, due to the time it takes for light to travel such immense distances, they would be seeing Earth as it was 65 million years ago, a time when dinosaurs roamed the planet. But here's where theory diverges from practice. The practicality of an alien actually observing dinosaurs is complicated by many factors. The resolution required to see something as small as a dinosaur from such a distance is beyond our current scientific capabilities. Furthermore, Earth's atmosphere would blur the image, making it virtually impossible to discern individual organisms. So, could an alien located 65 million light-years away from Earth see dinosaurs using a powerful telescope? Theoretically, yes. Practically, it's a different story. But isn't it fascinating to ponder such cosmic riddles? If you like what you see, please remember to subscribe to Time Pilgrimage and smash the notification bell. And as always, we are open to any topics that you would like us to explore. Thanks for watching.